This is the Reaction Stoichiometry Lab. Before we begin, you need to have access to the lab packet. You can print it out from Canvas, make all your recordings, your answers to your questions on the lab packet, then scan it and upload it and submit it for credit. You may also type directly into the lab packet, save it, and upload it. Now, because we are not on campus to actually do the lab, I went to school, performed the labs, and took pictures of the measurements that I was making. You are going to now then look at the measurements, record those in your data sheets, and complete the lab as if you were in class. To get full credit for this lab, you must have a completed data table, the pre-lab and the post-lab questions answered. I'll grade them just like I have been grading the labs that we're normally doing. So let's get started. So in this lab, we're going to make measurements that will allow us to calculate the coefficients from a balanced equation. Now, I use the law of conservation of mass to help me calculate the amount of reactants and products, because I know that the mass of my reactants should equal the mass of my products. Now, the reaction is a decomposition reaction represented here. The reactant was potassium chlorate. I heated it using a Bunsen burner, and that decomposed the potassium chlorate into two products. We have potassium chloride and oxygen. Now really, if you look down here at the steps, during the experiment, there was really only one thing I had to measure. I had to determine the masses of each one of these three reaction components, the potassium chlorate, the oxygen, and the potassium chloride. Once I do that, then everything else is a calculation. I'd calculate the number of moles from the mass using the molar mass, and then I would take a ratio of those moles by dividing all 3 moles by the smallest number of moles. Now, the actual calculation part is very similar to a lab that we did previously when we calculated the empirical formula of magnesium oxide. At the end of the lab, I will do an example of balancing the equation, calculating the number of moles from the mass, and then remind you about how to calculate the ratio. There's also an example in your packet right below this section in the packet. So let's take a look. So this setup looks similar to what we did when we did the empirical formula. Right here is what I was going to set up the experiment as. The first thing I did was got a crucible and a lid, and I cleaned it using hydrochloric acid. There was some bubbling as the hydrochloric acid reacted. And then after I let it sit there for about 5 minutes and the bubbling had stopped, I discarded the hydrochloric acid, rinsed it well, and then I heated the crucible on the Bunsen burner. There was nothing in the crucible at this time. I was simply trying to make sure that the crucible was clean and ready to use. Now, after I took the crucible off the ring stand and the triangle, I allowed it to cool, and I took my first measurement. So this is step 4 right here. And this is the measurement of the clean crucible and the cover. So you're going to need to record the mass on the balance for the clean crucible and the cover. Again, there was nothing in the crucible at this time. Then I got a sample of potassium chlorate. It looks very much like salt, table salt. And so here I was adding the potassium chlorate with a spatula to my crucible. Now, after it was completed, it told me to get about 2 grams. And when it says approximately 2 grams, it doesn't have to be exactly. So I got approximately 2 grams, and then I re-weighed it. So at step 6, I re-weighed the crucible, and now I had the mass of the crucible, the cover, and the potassium chlorate. So you're going to need to record the mass here. That includes the crucible, the cover, and the potassium chlorate. Now, so how would I determine the mass of my potassium chlorate? If you subtract the mass from number 6, from step number 6, and subtract the mass of just the crucible and cover, this would be the mass of the potassium chlorate that I put into the container, which I think is also a spot on your data sheet. That is a spot where the mass of the potassium chlorate is not under, it's under the second part of data. It's under calculated data. So read carefully your data sheet. Now I then set it up, and there was a step here on the bottom if you're following along in the procedure, which I encourage you to do. Letter A had me setting it all up and setting the lid ajar, but it wouldn't fit very well here. So the procedure part, step B, I was heating very carefully the crucible with the potassium chlorate. It was, as it decomposes, oxygen is escaping, and so there's lots of bubbles. So on letter B here, I was just heating it carefully. I tried to show you here the bubbles that are coming from the potassium chlorate. So you can see it actually turned into a liquid. And if you had been in lab, you would see there was a lot of bubbling going on. And different points there was more of bubbling as it went on. Once the bubbling subsides, on letter C, I heated it again for 15 more minutes. I took this picture showing you that I was heating it very intensely. The bottom of the crucible was starting to turn a little peach color. So after the heating, intense heating, I took the crucible and cover with the products left in it and set it to cool. And so you can see here on this step, on this picture here, I looked inside of it. There wasn't bubbling. It still had a little pink there because the crucible was hot. And then here I took a picture once it was cooled. So this first picture is when the product is still hot. And then finally on step 8, I took the cooled crucible and measured its mass. And so this is the mass of the product, which is the potassium chlorate. So this is the lid, the crucible, and the product, the potassium chloride, which is the product that remains. And so now with this number 8, you should have all 3 spots of your data recorded. And so then step 9 is to calculate the coefficients. So let's take a look at a few things so that you can think about what you need to calculate. So I mentioned earlier the mass of the potassium chlorate. So to calculate this, we would take the mass of the, our number 2, so we're going to take the mass of the crucible, the cover, and the potassium chlorate. And we would subtract the mass of just the crucible and the cover. And then that, if you look at it, gives you the mass of the potassium chlorate. Then the second mass we have to calculate, remember to perform this experiment, we have to know all of the masses. We would to find the mass of the potassium chloride, if you look back up at your data, we would take the mass of the crucible, the cover, and the potassium chloride. This was the last thing we measured. And you would subtract the mass of the crucible, the cover, just by itself. And so when we subtract, these 2 things will go away, and we just have the mass of the potassium chloride. And then finally, we need the mass of the oxygen. This is the third calculation so that we can have the masses of all of the components in the reaction. And for the mass of the oxygen, we use the law of conservation of mass, and we take the mass of the potassium chlorate, which we calculated up above, and we subtract the mass of the potassium chloride, which we just calculated. And if you look, the difference here is going to be the mass of the oxygen that remains. Now, I know you might think, but this says right here, O3. But recall, when chemicals are making different substances, they don't always have to keep the same ratios. That's what balancing the equation is for. So I'm going to do one of these for you so that I'm going to do an example of how to calculate the moles. And so I'm going to do the first example for you. So the mass of the crucible and cover I recorded is 19.904 grams. And then I recorded the mass when I included the almost 2 grams as 21.883 grams on my data. So now if I subtract these 2 numbers, I have the mass of the potassium chlorate. So 21.883 minus 19.904. And I get 1.979 grams. Okay, so I'm going to take that number and do an example of some of the other calculations. You're going to have to do the other ones. All right, so I know, the mass of the KClO3 is 1.979 grams. Now looking at my data sheet, I need to know the moles because the balanced equation is, to figure out the coefficients from the balanced equation, that comes from the ratio of the moles. So I need to know the number of moles. Okay, so to find moles, I'm going to need the molar mass. So the molar mass of KCl, so I have K, chlorine, and oxygen. I have 3 oxygens, and that's 16. I always know the oxygen, so what is this, 48? Now chlorine and potassium, I only have one of those in the formula, so I'm just going to use that. So let me get my periodic table, and you can use this opportunity to find a periodic table. And I need to find the mass of potassium. So it is 39.10. I'm rounding mine to 2 past this decimal. On my periodic table, it actually says 39.098, and you can use that if you want. And then chlorine is 35.45. And so to find the molar mass of potassium chlorate, I'm going to add all of these together. Now, this was one of the questions that if you've already done the pre-lab, you have already done this. So you know the molar masses of all of them because that was a question on the pre-lab. And I get 122.55 grams per mole. So this is the molar mass of potassium chlorate. All right, so to determine the moles, we're going to start with what's given. So I have 1.979 grams. That's what I calculated from lab. And we're going to divide, so put the molar mass on the bottom. So my units cancel. See, grams cancel. So I'm dividing by the molar mass to figure out the number of moles. So 1.979 divided by 122.55. And I get 0.0161. Let's see, I guess I can go to 4 significant figures. 1615. I'll just leave it at that. Again, at this particular problem, significant figures would not be extremely important because in the end, we're going to divide by the smallest to get the ratio. So here's another thing that you can put in your data sheet because under calculations, the first calculation says the moles of KClO3. So now to determine the moles of KCl and the moles of oxygen, you will use the grams that we determined and then divide each one by its respective molar mass. And then to find the ratio, which I am not going to do right here, but we'll be happy to answer questions about. I want you to try to do it. To figure out the ratio, once you have the moles of potassium chlorate, potassium chloride, and oxygen, if you divide them all by the smallest number of those moles, then you round those to a whole number and you'll have the whole number ratio. Now let's just review balancing the equation. And what we expect from this reaction, and then you're going to figure out if that's what the data shows. So what we expect when we balance an equation, remember we're following the law of conservation of mass. And so we're comparing the number of each type of atom from the reactant side to the product side to make sure that we have the same number. Again, following the law of conservation of mass. So potassium has 1 and potassium has 1. So that way I would do nothing. Chlorine has 1 and chlorine has 1. Nothing. Oxygen has 3 on this side and oxygen has 2. So that's not balanced. So if I got both of those up to 6, I could get 3 and a 2 both to 6. So for this one, I have to multiply by a 2. So I'm going to put the number 2 in front of here. And if I put the number 2 in front of there, 2 times 3 gives me 6. And then if I put the number 3 here, then 3 times 2 gives me 6. Now the problem is when I put this 2 here, it also affected the potassium and the chlorine. So now I have 2 potassium, but I only have 1 here. So sometimes, remember, we have to go back, and then I can put a 2 here, and then 2 times 1 would give me 2. And then I have 2 chlorine, and I have again 2 chlorine. So my balanced equation, what I would expect. So my expected balanced equation, by following the law of conservation of mass, and so this would be another way to say this. This is predicted. This is what I would expect or predict, is 2 KClO3 goes to 2 KCl plus 3O2. And so now what this lab is trying to do is experimentally see if that's the answer we get. So again, let me remind you, I know this is a little different than doing it in class, and I appreciate that you're giving it your best shot, and I hope that you have enough lab experience to kind of see what's going on. But what you have to do for the lab credit is you're going to complete the data page, the calculations, you'll do the pre-lab and the reflective exercises. And then you will upload them into Canvas, into the lab assignment part. And I will grade it as I normally grade it. It's worth 20 points. This is not a test. You can communicate with each other however you're doing that, via text or phone. And you can also please feel free to reach out to me, and I will help you work through the calculations or support you in any way I can. Keep up the good work, and let me know if you have any questions.